Okay, today we're going to be talking about inscribed angles and polygons. Inscribed just means to be drawn inside, whereas circumscribe means to be drawn around. The word scribe means to draw, and in means inside. Circum, like circumference, means around. So we would say that this angle over here is inscribed because the angle is inside the circle. You can see that there's two chords that intersect, and the vertex actually touches the edge of the circle, and that blue angle is the inscribed angle. You would say the intercepted arc is the arc that goes between that inscribed angle. And there's a very important theorem. It basically says that if your inscribed angle is, we'll go with this way for starters. If the intercepted arc is 80, the inscribed angle is half of that, so that angle there would be 40 degrees. Now this is different than what we did last week, where we had the central angle. The central angle, the angle that was in the middle of the circle, and the center of the circle, if this is 80 degrees, the central angle is also 80 degrees. But basically, it makes sense that if you have to go all the way to the other side of the circle, that angle would be smaller because pretty much the further away from those 2 points you get, the skinnier you're going to have to make that angle to catch that arc correctly. So hopefully this will help you to see that this has to be smaller, and it turns out it's exactly half the measure of the arc, and we're going to be using that a good bit. One other thing we're going to be using is inscribed polygons. Let's scroll and see those. An inscribed polygon just means all the vertices are on a circle. So we would say this polygon E, F, G, D, R. You could start alphabetically, call this polygon D, E, F, G. It's worth mentioning, by the way, you can't just go willy-nilly. You can't call this polygon D, E, G, F. That would not be correct because you have to kind of go D, E, F, G and kind of go around the polygon in a circular fashion, so that if you kept going, you would end up back where you started. You notice if you tried this one, D, E, you'd have to pick up your pencil to jump to G. So that's why that is not correct for naming that polygon. There's a very specific way. You can't just do them how it seems good to you. An inscribed circle, on the other hand, means the circle is actually inside, and then the polygon would be circumscribed around it. Now, if you have a right triangle that here, this right triangle is actually inscribed in this circle. But what this means is, if this is a right triangle, this is 90 degrees. So if that is 90 degrees, this is a inscribed angle for this arc here. So if that is 90 degrees, this is going to be 180 degrees. And if that is 180 degrees, that means this is a semicircle, so AC must be a diameter. So basically, this theorem, all it's saying is, if this is a right triangle, then that's a diameter, and A to C would be a semicircle. All of those things have to be true together. If this is not a right triangle, then you don't have a semicircle opposite. So like if you had something like this triangle is clearly not a right triangle. So since this is not a right triangle, then this angle is not equal to 180, which means that this line here, this intercepted chord, is not the diameter. That's what that theorem is saying. Now, the last one we have is about a quadrilateral, that is inscribed in a circle. And the unique thing here is that the opposite sides add up to 180. So like if I knew G was equal to 80 degrees, I would know that E, the opposite angle, would have to be 100 degrees. The reason this is you notice angle E catches the arc FGD, and you notice angle G catches or inscribes the arc FED. Between those two angles, between the arc caught by G and the arc intercepted or caught by E, it has the whole circle, which is 360 degrees. So since the angles that are inscribed are half of the arc, if the arcs add to 360, the angles add to 180 because it's half of 360. But that's why it works. But as long as you know the opposite angles are 180, you'll be good.